Hello everyone, my name is Ketuktula Zulu. I'm the man behind the content. The purpose of this channel is to make everyone that is in high school from grade 10, grade 11 and grade 12 to grow under mathematics. That is my purpose, to make everyone pass this subject. So now I would like to thank everyone who's been supporting me on this channel. Guys, thank you so much. I really appreciate your support. And another thing, please, if you are watching this video, you haven't subscribed, please subscribe, like, comment, tell me what I need to improve on, tell me what you want on this content. I really want to engage with you. Thank you so much, God, for supporting. Cheers.
Hey guys, Umakebalo. Thank you so much for supporting the channel. Keep on supporting the channel. We're going to continue with our revision based on question 1 of your question June question exam. So we'll be revising those types of question where most of them you just solve for x. Question 1 of this one, 1.1 into 1.1.1, it's saying 3x squared plus 5x then is equal to 2, and this one, solve for x, take 2 to the other side, we have 3x squared plus 5x, and then minus 2 is equal to 2. From here you can still factorize, or if you don't know how to factorize, you just put a quadratic formula, which is gonna make your things a little bit easy. But for me, I'm just gonna factorize just to save time. Just gonna be 3x and x, why 3x, because when I times this by this, it has to give me this 3x squared. Then another one, the factor, it's 1 and 2. Why 1 and 2? Because when I times this and this, has to give me this 2. But in terms of the sign, this is going to be negative, and then this one is going to be positive, because when negative times positive is negative. Now I need to get this positive 5. How I'm going to get this positive 5? When I times this and this, give me 6x, which is positive 6x, and then this and this going to give me negative 1x. And then 6 minus negative 1x is positive 5x. That's how I get this thing. And then it's equal to 0. And then 3x, solving now, this is going to be equal to 1, or x is equal to negative 2. Here, still solve for x, divide by 3, divide by 3, x cancels x, and x is equal to 1 over 3. You're done with this one, and you're done with this one. Thank you. Going to the second question, which is 1.1.2, it's saying root x plus 7 then minus 1 is equal to x. This type of question is the one where you need to make sure everything on the other side, it has a root. Before you do anything, make sure the end on a root, the specific thing that has a root like this one, it's alone on the one side. It's alone. Like what? Like just saying x into plus 7. Take this one to the other side where it's just x plus 1. Before you do anything, make sure the root thing, it's alone, and the other one, it's alone on the other side. Then from here you can just say square both sides, square both sides. What you do on the left hand side, you do it on the right hand side. So this root cancels this root, is just going to be x plus 7 into this is just x plus 1 into x plus 1. X plus 7 times this is just x squared plus x plus 1, then x plus 7, and x squared, x times x plus x is just 2x, then plus 1. Solve for x, take this to the other side, is equal to 0, and x squared plus 2x plus 1 is minus x, it's minus 1. Then x squared 2 minus x, it's just positive x, and then 1 minus 1, it's 0. Okay, sorry, it's 7 here, and then this is 7 here. Sorry, I made a mistake there. Then 1 minus 7, it's what? It's negative 6. Yeah, made a mistake. So sorry for that. And then from there we can just say 0 is equal to, factorize this thing, it's what? It's x, and x times x squared, factors of 6 is 3 and what? And 2. Now I need to get a negative 2, so we're gonna make this one positive and negative. We're saying this and this is negative, but we're saying 3 minus 2 is positive 1. So x is equal to negative 3, or x is equal to 2. The ones that is here with the root, you need to check your answers. It's very important to check your answers here, because not both of them, they are always the solution of this here. So checking here is just putting x into this original equation, where we say root, where there is x is negative 3 plus 7, then minus 1, gives you 1 on the left hand side, but now on the right hand side, when you're putting this x, it's just going to be negative, this one. So this one is not applicable. And then when you're putting 2, it gives you 2 on the other side, and then x is 2 here. So this one is what? Is the solution. So this one is not applicable. I hope you see it. I hope you understand everything. Continuing with 1.1.4, where we have 3 into x plus 3 into negative x plus 1, then times 5 is equal to 8. Then from this one, solving for x, it's a question from grade 11, where you solve for x by exponents. And then from here we can change this one by taking the negative, because we need to make the root to be the same. So how can you make the exponent, sorry, not the root, the exponent to be the same, like 3 into x, then plus, we can say 3, let's just first by separating this, 3 into negative x times 3 into 1, and then times 5 is equal to negative 8. We're separating these two, same base, we add the exponent, negative x plus 1 is just going to be the same as this. Then after that, because this now is not the same as this, there's nothing we can do, because we need to at least have this one, both of them be the same. Then what do we do here? We just say x 3 into x, and then plus, changing this now, making this negative x to a positive exponent, we say 1 over 3 into x, and then times this 3, then times this 5 is equal to 8. Then from this one, this now is the same as this, we can let this 3 into x is equal to k. Then we can just say k plus 1 over k. Then 3 times 5 is what? It's 15, isn't it? 3 times 5, 5, 10, 5, 10, 50, yes, is 15. Then is equal to 8. And then from here, this 1 over k times 15 is just k plus 15 over k is equal to 8. Then from here we can take what? The LCD. This is over 1. The LCD here is just k, then k, how many times goes to 1 goes to k, and then k times k, just k squared. K uyanga k 1 time, so just gonna have 1 times 15, and then 15, and then is equal to this 8, and then cross multiply here, just k squared plus 15, and then is equal to 8k. This k is gonna times this 8, then we have k squared, take this to the other side, is negative k, and then plus 15 is equal to 0. Then from here we can factorize. We can have k factors, it's 3, 5, positive, so we can make this negative and negative, because negative times negative is positive, is equal to 0, and k is equal to 3, or k is equal to 5. But to k we set k is equal to 3 into x, so it's equal to 3. Same base, drop the exponent, then x is equal to 1 here, then 3 into x is then is equal to 5. We can't make 5 and 3 be the same. What we can do, because now we are in grade 12, so in grade 12, if you are in grade 11, we can say this one there's no solution, but now because you are doing grade 12, we can use the logarithm here. We can say just x, the log of our base. What is our base? It's 3 into 5, and then punching your calculator, the log of 3 into 5 is just x is equal to 1,46, just like this. Thank you so much. Now we can continue with our question 1.2, where we have these typical questions where it needs a little bit of thinking, but the procedure of one of these questions is the same. Especially they are always like this. What we can do here, especially there at the top, using the factorization that you know, especially the common factor one, where we have, let's say we have x4 minus x7. From here, the common factor, it's always the lowest number. So x into 4 into 1 minus x into 3, because now x4 plus 3 is 7. I hope you understand that one. So we're going to use the same thing here at the top, where we have 20, 2015, and then 2 into 2015, and then 2 into 2013. So the smallest exponent here is 2013. So we can just say 2 into 2013. But now, to get 2015, if we take 2 into 2013, kuzosala bani here in this 2015? We're gonna left with 2 into 2, because when you add 2013 plus 20 plus this 2, we're gonna get 2015, and then we're gonna say plus 1 over. Now we can say here this 4, 2 into 2, changing this 4, coming back with this one, then 2 into 2013, then 2 into 2, then plus 1, and then this times this is just 2 into 2012. I hope you understand that one. And from here and here, we just use the exponent rule. Same base here, so we just take one base, 2013, then minus 2012 into 4 plus 1, 2013 minus 2012 is just 1. 4 plus 1 is 5. 2 times 5 is just 10. I hope you do get it. I hope you do get it. Just easy. Isn't it easy? No, it's not easy. It needs you to practice it. Thank you so much. Okay, going to question 2 now. This one, they are saying calculate the possible values of k if the roots of k, which is k x squared plus kx plus 1 is equal to 0, are non-real. So we must know if it's non-real, our determinant is equal to 0, is greater than 0, is less than 0. So our determinant when it's non-real is what? It's less than 0. It's very important to know this thing. Very, very, very important. So now, what is our determinant saying? Determinant is b squared minus 4ac is what? It's less than 0. Now we need to substitute our b. It's this one where we have k squared minus 4. Our a is what? It's k. Then our c is just what? Just 1, less than 0. K squared, this times this is just negative 4k less than 0. What is happening here? They are telling us that this is less than what? 0. So our function is less than 0. Just gonna draw a function here, which is k squared, meaning our function is up like this. So we have this function. We can just solve for x here, where we do the critical values, where just say k squared minus 4k. I'm just gonna put equal to, this is a critical values, just solving for k, taking k as a common factor, left with k, and 4 is equal to 0, then k is equal to 0, and then k is equal to 4. When I put these values of k, we have 0 and 4. But now here, very important, they are saying our function is less than 0. Our function is less than 0 where? Here, underneath the graph. This is the x-axis where the 0 is at, but now they are saying it's less than what? Less than 0. So we have 0, we have k, just say 0, k, and 4. So now when we have 0 here, we are going to the values that are bigger than what? Than 0. So 0 is less than. So 0 is less than. When you are in this side, 4 going this side, 4 is what? Is bigger than the values b, because we have 3 here, we have 2 here, we have 1 here. So 4 is bigger than these values. So 4 is bigger than these values, and these values are k, where those values are smaller than 4. So this is how you solve this typical question. Thank you so much. Okay guys, we'll continue with question 2, which is the last part of this video, which is 2.2, where we are solving simultaneously. So we have 2x plus 1 is equal to 4y, and we have x squared 2y is equal to 3. Simultaneous equation. Solve these two equations simultaneously. First, we need to make y or x the subject of the formula between these two equations. Here we have something that is x squared, so let's just put it there, this one here. First thing is, we can call this equation here equation number 1. You can call this one equation number 2, but let's simplify this one, since we can able to simplify it. We can just say 2 into x plus 1, and 2 into 2, the prime factor of this one is 2 into 2, then times this y, just going to be 2y. 2 and 2, same base, we can drop the exponents if we have equal signs, so x plus 1 is equal to 2y. We have x where we have x which is coefficient there corner, it's 1, so we can take this one to the other side, make x the substitute of the formula, just gonna be 2y minus 1, so we can call this our equation number 3. Then from this point we can say substitute equation number 3 into equation number 2. What is our equation number 2? It's x squared plus 2y is equal to 3. What is equation number 3 saying? Is saying where there is x, we put 2y minus 1. So like no x corner, we say 2y minus 1 all squared, then plus 2y is equal to 3. Then from here, this thing just means we have 2y minus y, 2y minus 1, then plus 2y, take this 3, minus 3 is equal to 0. And from here, we can just times here, open the bracket, 2 times 2 is 4, y minus 2y minus 2y, then this and this just positive 1 plus 2y minus 3 is equal to 0 for y squared. Like terms, this cancels this, we have 2 minus y, 1 minus 3 is just minus 2 is equal to 0. From here you can take common factor of 2. I hope you see it. If there is no common factor here, we can just say divide by 4, not 4, divide by 2. If you don't want to take common factor, we can divide by 2. Divide by 2, we're going to left with 2y squared minus 1, which is y, and then minus y is equal to 2. From here we can factorize this thing. We're just going to have 2y and y, and then we're going to just have 1 and 1, and then most important, the equal sign is just go negative and positive, times this and this give us this negative 1. And then how do we get this negative here? This times this, it's 2y, and then this times this is negative, this times this is negative 2y, and then this times this is positive y, which give us what? Negative y. And from here we should just say 2y is equal to negative 1, y, or y is equal to 1. Continue here, which is these two y's solved by x. Now we are not done. Substitute this our y's into this equation, where we have y which is negative 1 over 2, and then minus 1 on this one, then to 1, and then negative 1. Punch your calculator. On this one you get 2, negative 2. On this one we get 1, and we are done with your simultaneous equation. Thank you so much.